All right, let's see if this actually works. All right, let's see if this actually works. All right, let's see if this actually works. Oh dear, echo, echo, echo. That was unfortunate. Important things first. I have a tasty beverage. I would recommend that you all get a tasty beverage. It will make things so much easier. Beyond that, today I am going to try to do some general testing and possibly some unbreaking of carp. How did all of this happen? Why am I touching carp? Well, mostly because I'm an idiot and I don't know when to leave well enough alone. Such is life. The reason I wound up looking at this is because I happen to know about 200.319, which is a crash when you combine the bridge and carp, and I have been fiddling with the bridge because of, well, this, and also, and especially because of this. I have done some work on the bridge to make it somewhat faster. Actually, I have the numbers here from 3.7 million packets a second to 18.6, which I'm sure you'll all agree is somewhat faster. And that actually might fix this bug. So I figured I'd test that. And, well, we might as well immediately log into the Shiny test machine. Where I have a test case PR2 mumble, which does this setup, and then we run it, and then it should be sending ping messages. But what actually happens is well, this, where it panics because we are not in NetEpic, somewhere in carp. Which in this case is actually fairly obvious. There's a soft clock, there's a callback somewhere for something that doesn't enter the epic when it should be, and then it tries to send packets, and then things explode. In the interest of making things not explode, we'll take a crash dump and reboot this machine. Welcome, Olivier. I hope you're doing well. We'll take a crash dump, reset this machine, and take a look at what might have happened there. I'm cheating slightly because I've actually already have a fix for this, but we'll just run through it again for shits and giggles. What I'm hoping to do is get a fix ready to commit, possibly even commit it, and maybe even write a test for this. What I'm certain I will achieve is, having my drink. Tasty, tasty. So this thing is writing its crash dump. One of the wonderful, wonderful things about developing FreeBSD is these crash dumps. System panics and you get, a core dump where you can go examine things. It's delightful. This is a safe and controlled environment. It is in fact safe to drink and sudo here, as you will discover very soon when I start doing this. Let's get a second console open there. Well, work better if we SSH to the correct machine. And grab our backtrace. This one will probably look familiar. And we can get a full backtrace, and we can even go look at, So this happened in carp, where we triggered an assertion and we were not in fact in that assertion. So let's grab our carp code. And now you're all discovering how terrible my typing is. So what happens here? Well, we NetEpic assert, which means that we should be in an epic for the network. And where are we coming from? We came from carp send AD locked. Wonderful thing about FreeBSD coding style is your functions start at the end of the line. So when you're searching for them, you can go start of line and name a function. And rather than finding all of the places where it's called, you find, hey, look, this is where the function is actually implemented. That's great. So this ends up doing a call to best IFA, and oh, actually this function. Oh, well, would you look at this? Somebody has fixed this problem. Oh, no, somebody has not, in fact, done this. We can fix this problem by doing this, except that there's a go-to here that we might need to cover as well, which means we should have to do this. Basically, the problem is that we're manipulating data structures that are epoch protected, and we're not going to get into epoch here. Well, if people are interested in that, we'll walk through what I did to the bridge at some later date. But this is interesting because we already enter epoch somewhere, but we have calls to functions that don't enter them. And actually, what we're going to do is do this. We're going to widen the area that's covered by the epoch enter and exit, and we're going to widen it substantially. So if this were a regular lock, that would be a bad idea, because you want to keep the area that you cover with locks as small as possible. But because epochs, because multiple threads can be in an epoch at the same time, it doesn't matter that it's big, as long as we get out of it eventually. That's good enough. Where do we end up? Yeah, there are no obvious returns here, because of course what we do not want to do is enter it and forget to exit it, because then things will go badly wrong as well. This looks a lot more likely to work. So why don't we do a very fast kernel build and see if this explodes. It may not feel good to learn this, but it turns out that that a lot of this kernel development stuff is, try and see if it explodes. Can people in fact hear me? It would be wonderful if you'd say yes in the chat, because otherwise I'd just be talking to myself and that would be stupid. Oh, good. Thank you very much. If you're interested in asking questions, there's a Jitsi stream posted in chat somewhere higher up that you should be able to join and hear yourself. You might want to mute the stream if you're doing that, because echoes are no fun. And so, build kernel, install kernel, reboot, retry, see it, watch it explodes, and so forth and so further. That's how it commonly goes. It's generally fun to have a nice and fast machine to do these sorts of things on, and also it not be your desktop, because if it's your desktop and you keep panicking it, you're going to have a bad time. Of course, that's a lot harder if you're one of those crazy people who support desktop environments on FreeBSD. And there, hang on, we only want to install the kernel. Welcome, Ed. Say hello to the nice people. You're not muted, I can hear you, and hopefully the rest of the stream can hear you as well. Oh, we can't hear Ed. I may have messed up my configuration here. That's a shame. That should be working. I don't know why that wouldn't be working. Nope, I've got nothing. If it doesn't work, we're going to have to do without Ed. Well, Ed can say things to me and I'll try to remember to repeat them. We can reboot this machine and we can see if it decides to panic again. Now that I know that Ed is listening, Ed, you promised to review some code for me. Ed is going to be one of the nice people who's going to review the bridge code for me, and I was reminded of our wonderful internal metaphor of bike shedding, because people are always a lot keener to review, the small and easy commits, and when you start messing with locking on the bridge, nobody's interested in looking at that. Ooh, I'm getting echoes. Ah, I see Olivier has joined us as well. Welcome, welcome. And our machine has decided to be booted again. Test cases PR 200 something. What happens if we run it now? Well, what we get is another panic, but a different one. So that we'll call that progress. So dump the state, reboot the machine, wait for it to load. Wait for it to reboot. There's an awful lot of sitting around and waiting for things when you do this. Hence the tasty beverage. There we go. Saving core while it's booting. Feel free to ask questions if things are not obvious, because this is I'm threading through this again because I'd already sort of fixed these issues. Can't type. And here's the other backtrace. So what happened here? We're in carp master down, which also does a send AD locked, oh, does a net epic enter, oh, it's down locked, it's ARP announce, which presumably gets called through carp, and yeah, there we go. So this is, right, so this is the path through which we crash. We get called into, we get a call out, which is just a function that gets called after a certain amount of time. And that is unlocked. Then we take the carp lock, we set the correct VNet, we enter carp master down locked. And one of the things that we do as part of that is we send ARP. Now, there are a couple of things that we could, we send ARP, and that does an ARP announce IF adder. Oh, I don't have my C-scope set up. That's unfortunate. So we're going to have to wait for that one again. So the interesting thing here is, there are two interesting things here. Come on, find my run the C-scope so I can jump around in code, because otherwise it's going to be. Otherwise, I'm going to have to try to demonstrate that I know where code lives in R3, and I just don't know that. That's what C-scope is for. Yes, but we did hit. Actually, we can. Well, not so much cheat as use another way to figure this out. We end up entering ARP requests, ARP request internal, down rather, asserts that we're in Epic, so that's what we expect. So we need to be in Epic to enter this, so we could do, well, a net epic assert here when we, just so that we know when we need to call it. And then the amusing thing here was, yes, that we hit not just this, but send AD locked. does a net epic enter for us, which is, well, interesting, because the what I would be inclined to do here is net epic enter from carp master down, or carp master down locked, depending. But then we'll enter it and enter it again, and we can get away with that. That is allowed, but it's a bit silly. It's doing additional work when we don't need to be doing that work. So there are two things we could do about that. We could enter it from where we call the send arp, so we could do a net epic enter here rather than an assert, which would work. But then we enter and exit here, enter and exit here, which is also slightly silly. So where do we carp send AD locked? From carp send all, carp send AD. Okay. Oh, and from our carp master down locked. AD all is a task. Is a task that could be getting called. Actually, don't even. Oh, yeah. Okay. So we might have to enter it here to safely enter carp send AD locked. The thinking being that can we extract the epic entering from carp send locked, and we have a carp send AD, which is an epic, which would also be, which is a callback rather, which would make this a sensible place to do a net epic enter, so we can widen it. That seems like a reasonable thing to do. So let's try that one. We've got calls to this. Oh wow, carp input C is already in epic, so carp master down locked could conceivably also be in. So we could, let's epic assert in the down locked and enter it here. To enter in ARP epic, we need an ARP epic context, so this, and then we can let's epic exit here, which means that we will be okay when we hit this one. We've added an assertion because assertions are just always a good idea. We should always assert all of the things. And then we can net epic assert here and remove the exit, which means we also don't need the net epic tracker here anymore, but we need to be careful that when we enter it that we are epic locked. So where can we get called? We can get called from send AD and send AD all. So net epic enter. Oh, yes, we can just grab these two, and we can, no need for a blank line for our locking, and we can, let's epic exit ET, there we go. That looks sane, except we need to remember to exit it here. So where do we call send AD? That's call out. Yeah, that's call out. That's the implementation. Where do we call send AD all? That is a task, and then we enter epic there as well. Send AD locked is now asserting that it must be called from epic, and that looks like it would be correct. Do we have any? Yeah, okay, we've I like this about Git. When we ask for a diff, it will show us where we have extraneous white space. So line 1131, might as well get rid of this now, before we build and install and test again and see what explodes. Ah, it doesn't compile. Okay, things not compiling is not good. Why does it not compile? It does not compile because we should be passing an address for our context rather than so this needs to be is that right? Presumably, yeah, but hang on, exit is going to want that as well, of course. We need to pass pointers to it rather than the variable itself, which is not right because does not match my recollection. See, that is not in fact correct. Okay. And there we go. We don't need an epoch context, we need an epoch tracker. Which only goes to show that I don't pay attention when I do these things. I have no idea why people trust me to write code in their kernel. But, you know, I didn't say that. Okay, so that's building. That is awesome. That's compiled. We can reinstall, reboot, retry, and watch it explode somewhere else. Or maybe not. Or maybe it won't explode. Maybe this will be a fix. Okay. Well, exit Vim and reboot. Because of course, if you want to test your change, it's important to actually be running that change. Go ahead, ask me how I figured that one out. So I'm being asked what I'm using to build and test on. I do the vast majority of my development in Beehive. So I rent a machine at Hetzner in Germany. I have a physical box. For not too much money, I get a fairly fast machine. And I run, well, that machine does my email and my web server and all sorts of, moderately important tasks. And I run Beehive because it's the fastest machine I have access to. Well, that one and another one I rent for other development work. So I run Beehive because, well, as you can see, it's a lot more pleasant to panic a VM than it is to panic a physical machine. And then I can get backtraces and I can do things to it, and it doesn't hurt too much when things explode. Well, there's forgetting to install things. There's forgetting to apply changes. Because I do a lot of embedded development, I also frequently discover that cables work best when you plug in both ends. So let's run this test again. And okay. It's not working, but it's also not panicking, which we will consider to be progress. So that's all very good. Let's let this run for a little bit. Actually, what we should do, if we were clever, is what does this setup create? Well, we load a bunch of modules. We load a bunch of modules. We random name jails, which is a good idea in general, but makes debugging this slightly more annoying than it needs to be. We create bridges. We create e-pairs. Oh, we do nested jails, I think. Oh no, we don't. We just. Oh yes. Yes. No. Yes. No. Maybe yes. Okay, so we shove the interfaces off to a different jail. We bridge our ePair 1 and 2B together. We set them up. We configure the bridge. You know what I'm missing here? Yeah. JExec1 should be fine. Did we set our bridge up? We did. Okay. So that bridge is up, that's connecting the two other jails. They both have a bridge that contains the ePair interface on which we have set carp addresses. So what I want to do is I want to JExec into the primary jail, and I want to see if I can ping, say, this bridge address. I cannot. I also cannot ping the carp address. Can I ping IP3? I cannot, but I can ping myself. Okay, so that's something. We should have a second jail, 2 bins sh, which contains ePair 1A. This bridge has an IP address. This bridge is up. We can ping ourselves, but we cannot ping number 4. Why would that be? We're seeing, oh right, this is our test process that's still pinging away, trying to reach that address and not actually getting anywhere. We're going to kill that for a second because that's not helping anything. Because when I look at packet captures, I generally prefer to only see a little bit of traffic. So what do we see? When we stop pinging for a second, what do we see? We get an ARP request for who has... Okay, so we... What? Okay, that's strange. We are in jail number 1. Our traffic should be going out ePair 1B, and I am not actually... Okay, need another terminal. Let's have another one where we can ping. Just one ping only here, and this should be going out, yeah. Let's look at ePair 1B and ePair 1A. Okay, and then if we ping over the bridge, if we use ping correctly, we will see that we sent an ARP request for who has the .4 IP address. We are .2, so we're using the .2 address to ask who .4 is. We've sent that question out, and we have actually seen that question arrive here. But we are 10.255.255.4. So why does that not work? ePair 2B, ePair 1B, they are all members. Our bridge is up. It's in learning mode. It's learning, yes, that's good. Our ePairs are up, and yet we don't seem to... I don't understand this one. I really don't understand this one. And I am quite tempted to say that I'm going to investigate that one when I've not had most of a tasty beverage, because I have no idea what's going on. Is someone paying more attention? Can someone point me to what I'm missing? Because our bridges are up, our traffic goes out. Our traffic goes out. Why? Ethernet address 1F. That's the same, of course, because that's the same jail. Our MAC addresses at least appear to be oh, well, that's interesting. We have bridge 0 in our first jail, and we have bridge 0 in our second jail. And these are VNet interfaces, so these bridges are different, but they have... Am I misreading this? No, 58, 9C, FC, 10, 93, 1F. What we appear to have is two different bridge instances with the same MAC address. So that's interesting, and that is almost certainly why this isn't working. Let's see if I can remember how to change a MAC address. Turns out that I can't. I think I'm doing the Linux thing. And I can't type, which is also unhelpful. And now we have a different MAC address. So what happens now when we TCP dump? And we try to ping. Oh, would you look at that? We got an answer. So that, and not only that, we are getting traffic over our carp interface. Our carp address seems to be working. So I think we've managed to assign addresses. Yeah, so Olivier points out that e-pairs and jails and MAC address conflicts is an old problem, but he says that he's never seen it on a bridge interface, and I can't remember having seen that either, so I think this is possibly a bridge problem, when it is strange because my recollection was that the bridge takes the MAC address of the first interface we insert in the bridge. So we can stop pinging for a second, and we can... Oh no, we don't. That is an optional thing to do. I'm going to look at this problem later. We're going to try to finish this thing first, because I think if we look at this, our e-pairs, at least 1A 202.3D EE32170B. Oh, that's 2. 1F6B 2D 690B and 0A. That is, yeah, so our e-pairs at least have nicely different MAC addresses. So that's all good, but our bridge does not. We're going to have to work out, and I will attempt to remind myself of this. Let's kick off OmniFocus. If it decides to start, yes, and you don't actually need to see what else is on my to-do list. Whoops. So what I'm going to do is investment bridges in created with the same MAC FreeBSD, and we'll look at this on Saturday or something. Now this will go and bug me about having to do this at some point in the hopefully not too distant future, because this is a different problem. We've fixed the panics, and it looks like this will work as soon as we fix the bridge doing the wrong thing. So that's all excellent. So now we have a fix and another problem to look at some indefinite point in the future, because I'm only going to fix so many problems at once. What I want to do, or want to try to do at least, is write a quick test case that provokes the problems that we are currently trying to fix. And to do this, we're going to break the kernel again. Git stash is a wonderful thing. It lets me set these changes aside. So now all of a sudden we don't have those changes anymore. We can kern fast and it builds the kernel while we're doing things. And in the meantime, we can go look at where would be a useful location for a carp test. Do we have any carp tests? Of course we don't have any carp tests. Nobody's gotten around to writing any of the carp tests. So why don't we try to write a quick carp test? Let's try not to spill beer on us again. So a useful place for that would be to live under the source tree in tests sysnet, because we've already got bridge tests in there, kindly sponsored by the FreeBSD Foundation. We've got an e-pair test in there, and I think I wrote that 1, 2, yes. We had an input validation problem in e-pairs discovered by Ilya, and I'm blanking on his last name. Ilya's been finding a lot of security bugs in FreeBSD, so well done him. And this triggered it. Well, mostly what it triggered was a panic, but Ilya says it's exploitable, and I'm not going to second guess him. So we've got a test for this, so that if somebody manages to break this again, at least we're going to notice. We've got a bridge test, and the bridge test is probably the one we want to look at as an example. Yeah, there's no point in adding test because we're already in the test directory, so we'll just do this. These are the bridge tests. These are the carp tests. We'll need this. We'll want it to be... well, we'll do this. We'll copy the copyright header, because if I forget to add a copyright header, people are going to complain. But this one, the foundation is not paying for, so... This one's mine. We want VNet support. We'll want some of the utility scripts there. Test case carp basic. And we'll want a cleanup function. Carp basic head. This is the entry point for our tests, where we ATF set description. Basic carp test. And we need to be root to run these tests. Carp basic body, where we will implement the test. VNet init, but we can only run this test if the carp module is loaded. And in general, we try to avoid loading kernel modules during our automated tests. Instead, we have the CI framework load kernel modules that we will want to test. So I'm going to, we'll do the main body. We'll finish the main body, setting up the main body of the test first. Carp basic cleanup, which only needs VNet cleanup, which is easy enough. And then we want to ATF add test case carp basic. And that should be pretty much all we need. Well, one more thing that we need to remember to do is add this to the list of tests. This test doesn't actually do anything just yet. Let's cheat and use go look at how PF does the check. PF init. Oh right. Oh, there we go. We can steal this one. So what we want to do is only run this test if we've got not PF sync, of course, but the carp module loaded. This test requires carp. And so if the carp module is not loaded, we'll just skip the test. We can make and install this. In the meantime, our broken kernel has been rebuilt, so we can install that one. We've installed the new test, so if we queue a list, we should have... Oh, okay, so I did something wrong. We have IF carp, but we don't have a test cases list. So clearly I've done something. So if you see this, that means something's wrong in your test, in how things are hooked up somehow. And I don't see offhand what that would be, but it has to be something. We've got an ATF test case. We've got a carp basic head, carp basic body. Why? So probably what this means is there's been an error executing this file, this carp sh file. It's just that I don't see offhand why that might be happening. If chat sees why this is happening, please do break in and tell me. Yeah. So I don't see offhand what I'm forgetting, what might be causing this to fail. So what we can do is if carp. Ah, okay. There's a syntax error in our script somewhere. On line 54, we have an unexpected. Oh, I think. Nope, still. Okay. So these line up. These line up. These line up. And these line up, and yet when we try to execute it, yeah, but what might be interesting, remember how we just talked about, actually installing the code you're trying to test? Yeah, see, this is much better. There we go, now we've got our basic test case. Queue a debug, because debug will give us more output, and this test passes. It passes because we've got carp loaded, and it doesn't actually do anything, so this test is always going to pass, but we can KLD unload carp, except we can't because it's in use. Okay. Actually, we're just going to be lazy here. We're not going to tear these gels down, we're just going to reboot the box, because once we've rebooted the box, we can continue writing our test to such a way that it will, panic. Because that's what we want this test to do. So depending on the bug, I mean, for this bug I had a test script, so I just used that test script. But for a lot of other bugs, I will write the test script before I write the fix, because that's convenient, because then I can use the test script to panic the machine, the automated ATF QA test. This one, it wasn't necessary because I had a test script that triggered the panic. I can't type my passwords. Tests sys and net. QA tests, QA debug, carp, and this should now skip because the carp module is not loaded. And this works, so that's pretty excellent. Tests sys net. And what we're going to do to make our life slightly easier, there we go. We can test this one. We can KLD loads carp, and then the next time we try to run it, it will actually try to execute. So that's all good. Test cases PR 2009. This is what the script does. I actually don't know if we need all of this, but we might as well, because actually this is a reasonable test to turn into a basic end-to-end test where we will actually set up carp, make it negotiate a which of the VNet jails is in charge of the IP address, try to ping it, make sure that it works. Yes, I'm going to completely agree with what Olivier says here, and that is that as a simple FreeBSD user, not a developer, although I don't know if I'd agree to describe Olivier as a simple user, because Olivier understands how things work on the inside a lot better than a lot of other users. But I will agree with the rest of his statement that one of the best things you can do as a not developer is contribute a regression test that provokes a panic or incorrect functionality or a missing feature or whatever. Honestly, when I fix bugs for PF, quite often half or more of my time I spend on trying to reproduce the bug that the user is reporting, rather than on actually investigating, why does this panic? How can we fix this? You've seen how long it took to walk through, why does carp panic? It took 5 minutes to fix, it took 15 minutes to fix. It took 2 minutes to figure out what the problem was, and it was very, very easy to figure out what the problem was because we had a test script that reproduced the problem. So if you have a pet bug that's just not getting fixed, consider writing a test for it. It not only helps us ensure, it's half of the work that I need to do, so I could theoretically fix twice as many bugs if people would write the test scripts for me. Theoretically, probably not in practice, but still, it's very helpful. And it will also make sure that if there's an automated test, it's not as likely to break again. So anyway, writing this test, what do we need to do? We need 3 jails. We'll just try to get the same equivalent functionality that we've got here. So we'll need 3 jails, one of which will have a bridge and 2 e-pairs. The other one will have a bridge, and the other 2 will have a bridge and a single e-pair. We're actually combining a bridging problem here, and I'm not sure that we need to throw that in the basic test, but we might as well. It's not going to do much by way of harm, so well, let's see if we can reproduce this problem with just this one bug. So we create a bridge with, did we have MK bridge? I forget. It's not as if I can remember how all of these things work. We can make e-pairs and bridges. So let's right quick copy this as a cheat sheet. We've got VNet MK bridge. We've got e-pair 1 is VNet MK e-pair. E-pair 2 is VNet MK e-pair. Jill, what will we call this? Well, we'll call this 1. I'm not feeling particularly inspired, and you get the bridge, and you get e-pair 1A, and you get e-pair 2A, and this will work better if we spell it correctly. VNet MK jail 2, and you get only e-pair 1B, VNet MK jail 3, and you get e-pair to B. So what we end up with here is 3 jails where the first jail will bridge E pairs to those 2 jails together. So we want to jexec1if config bridge, and we want to give it an IP address. What IP address do we want to use for this? 192.0.2. Let's give him 4 to match our other jail, and let's do 29, and let's set it up. And we want to add E pair 1A and E pair 2A, and we also want to make sure that those are up. Thank you, Olivia. That is very helpful. That's jail 1. We want now jail 2. If config E pair 1 B 192.0.0, and well, you can be 2/29. And we also want to set the carp there. So if config E pair 1B, add vhid1, and we'll give it IP address 192.0.0. Well, let's say 1/29, and then we do basically the same thing for 3, except this is E pair 2. We do the same vhid add, but you do get IP address 3, of course. And then we want to ping, yes, jexec1 ping -c, let's give it, well, let's just ping 10 packets. And we want to ping to 192.0.0.1. Actually, what we're going to do here is we're going to give that a couple of seconds to stabilize. We'll remove this because we don't need it, and then the next thing that we need is user source test system pfill pf, pf sync, whatever, because I can't remember the ATF test syntax, and of course I've managed to pick a test that doesn't have it. So what we want to do is ATF check, so that if this command fails, the test will fail. We expect exit status 0. We're going to do that command, but the one thing that we do need to do is explain to it that we don't want the output, and I'm sure I've got one around here somewhere that does that. I'm sure I've got someone around, I've got a test around here somewhere that does an ATF test and tells it to ignore the output, because I can't remember how that works. Ah, there we go. So ignore the output, run the ping command, run 10 pings from the first jail to the other jails. Okay, so I'll just sync all those ZFS should be safe, make install, and if we run this test, oh, would you look at that, we've managed to reproduce our panic. So that's pretty good. That's also why I hit the sync button, because ZFS or not, I want to make sure that things got persisted to disk before we actually panicked the machine. So this is good, we're back up, there we go, that has decided to Okay, so what we're going to do, not sys tests, sys net, yep, net. I have carp.sh, so we'll add the carp test. We'll add the makefile changes and we'll commit this because this test looks like it might be good. And we'll just say that we're attempting to provoke some epic issues here. That all seems to be fine. And what we're going to do now is see if that test, right, it's stash pop, so that our fixes that we did earlier, all of this, can be reinstalled. Actually, I could just reboot and boot the old kernel, but it's a fast build. And then we'll install the fix and we'll see if the test actually runs with the fix. That's the kernel linked, and then we want to install it. And we might as well immediately do the reboot. And with any luck, our test will actually pass. Of course, if it doesn't, we've got another problem that we're debugging a test, and that's always a pain in the behind. But we've provoked the bug, and it only took us, what, 10 minutes to write this test? I mean, it takes a little bit longer if you've never done one of these tests before, but Olivier's done some of these tests, and it's... I don't mean to suggest that if Olivier can do it, anyone can do it, but mostly I want Olivier to agree that it's not actually very hard to write these tests. And VNet makes it just so enjoyable makes it just so easy to write tests for all of these things. And what I've also discovered is that even a very, very basic test like the one we just wrote, because we're not testing any advanced scenarios, we're not testing failovers, we're not testing any really complicated carp functionality, we're not even throwing a lot of traffic over it, and yet it provokes panics. It turns out you get a lot of return for relatively little investment from these tests. I've done bridging work, performance improvements. I've done PF sync performance improvements, and even very basic tests will reveal any number of bugs and panics while you're doing development. It is so incredibly useful. So we can QA debug this test, and what we're going to notice, of course, is that it doesn't actually work because we don't have the module loaded. But if we try this, what do we see? Well, no panic so far. One of the annoying things I find with QA is that when you run debug, you don't actually get your output until it has completed. And what we see here is that our test passes. Rather than panicking the machine, our test now passes. That is also a problem, but we're not going to worry about this problem just yet. What we're going to do is commit this test. And actually, we're not going to commit it. Who maintains carp these days? House. Oh, it's I. carp for some reason. So who owns this? Who's the last person to touch this? Who can we bug with a review for this code? Oh, Cactus has been touching things all over the tree. Glub has also been doing things all over the tree. There we go. We can bug Mav. We'll and Bjorn we'll bug a couple of people. We'll post this for review. We're not actually going to commit it, but because I figure I should demonstrate a commit, I'll push some of the bridge changes I've done. The one that everybody's agreed on is a good idea already. So we'll commit this to my local Git tree. Right, so you need to add things before you commit them. There we go. What we'll do is we'll make a reference to this particular panic. Expects code to be running inside the nuts. Leads to panics. There we go, and we'll indent this slightly. There we go, so that's reasonable enough, and we've also got a test to cover this. When we commit it, I generally commit these things in reverse order. That is, I'll commit the fix and then I'll commit the test. Reasoning being that then the tests will never fail if it turns out that the CI system started building in between my two commits, for example. Okay, so we've got a reasonable patch, I think. Yep, so this looks reasonable enough. What we can do now is remember this hash, and I've got arc. Is our Git set up? Yes, there we go. We'll copy Mav and we'll copy Ed as well, just because. And that is really all it takes once you've got ArcGit set up, and this will. Oh, right. It gets annoyed when you have untracked files, so we'll just delete those. I should check if there's a command line option to make it ignore untracked files, because I know I didn't add any new files, so I didn't actually need this. So this is going to create a couple of local branches for me to make it easier to rebase changes if people disagree with the review, but we've got this pushed out to Fabricator so that people can review this. And while we're at it, we might as well push this one too. I'm not sure that people are going to review this one, but hey, now they can't complain that they didn't get the opportunity for review. So there we go. That will do just nicely, and I think to close this out for today, because I'm nearly out of beer, we're going to commit this one because it's had 3 reviews. We've addressed Philip's remarks because this patch is, I don't expect you to read all of this. This patch is pretty trivial anyway. We might as well commit it. I'm going to be very careful here. and actually download the patch again so that I commit exactly what was reviewed. First thing we need to do is update our subversion tree, which takes a while because, subversion is slow. It's really, really slow with everything. Interesting anecdote while we're waiting is I've taken to asking customers and potential customers, in the general job interview thing when I meet them, what do you guys use for version control system? And I ask this not so much because I particularly care about what people use. Is this actually? Yeah, okay. But because I want to know that the answer is something vaguely reasonable. And my definition of vaguely reasonable for version control systems is, we use Git, we use Perforce, we use Mercurial, we use Subversion. Those are all perfectly reasonable version control systems to be using. And I think the majority of my customers are either on Git or Subversion. Sorry. Those are perfectly reasonable version control systems to be using. Perforce is reasonable. The answers that I don't want to hear are things like, we're on CVS. Because really you should have moved away from CVS at least 10 years ago. Several years before the FreeBSD project did, in fact. I also don't want to hear, we're running ClearCase. Because one of the first places I ever worked ran ClearCase, and the scars still have not healed. What I definitely don't want to hear is version control. What's version control? We just create a copy of the file, and then we shout at each other when we're trying to edit them at the same time. That's definitely not something that you want to hear. So that's why I ask. Subversion, honestly. My verdict on Subversion is that it's not particularly great at anything, but it covers all of the strict requirements for a version control system adequately. It's just good enough to be reasonable. Not great, but good enough. It's adequate. It's not an unreasonable system to be using. I do my development in Git because it brings a lot of features to the table that make my life so much easier. I can do commits locally, I can reorder them, I can change them. You've seen me commit the 2 changes that we have done today for these carp fixes, and they're nice and out of the way, and I can work on them, and I can create reviews from them, and if people have remarks on them, I can change them again. That's wonderful. It's really, really nice, and it makes life easier. But I could just have a patch file with Subversion. It's slightly more annoying than doing it in Git, but it's possible. Anyway, what we want to do is patch-i. We want to apply this patch, and we want to apply the right one. And that applies cleanly. Well, it applies cleanly. Well, we'll just do a really quick build just to make sure that this isn't going to blow up too much. And while this is building, actually, I can nope. I can start writing my commit message. Well, I say writing. I have, of course, already written the commit message. I'm not going to test this new kernel. I just want to make sure, as a smoke test, that it actually compiles. And so we have our commit message. While I'm on my horse about talking about version control systems, commit messages are important. Explain in your commit message why you are making this change. So what I've done here, my usual pattern for commit messages is the area that I'm touching. So in this case, I'm touching the bridge, and a quick headline of what we're doing. This particular commit, change lists to CK lists as a preparation for epichification, which, okay, fair enough, is not a word, but people who are going to be touching the bridge will understand what this is for. Prepare the ground for a rework of the bridge locking approach. We will use an epic-based approach in the data path to make it safe to iterate over the interface span and RT node lists without holding the bridge lock. Replace the relevant lists by their concurrency kit equivalents. No functional change in this commit. And that is true. This commit does not make any difference whatsoever. Why are we doing it? Because it makes the next commit easier to understand. This work, proudly sponsored by the FreeBSD Foundation. Just as soon as they pay, just as soon as I write an invoice and they pay it, but that's all fine. It's been reviewed. Oh, right. What we're missing is the submitted by, sponsored by. Might as well add the reviewed by tag, which is must AE and Philip, which was a previous version, but Philip had a remark on my commit, which is that I had a stray addition in this commit that did not actually belong there. So he kindly pointed that out to me and I removed it. We've also fixed an overly long line that Ed pointed out, so we fixed that as well. And everyone else, we had AE, I keep forgetting the man's first name. Andre also looked at this and decided that it was good. So this is all good, this is all happy, and I'm just chatting while I'm waiting for this to compile. Oh, did I mistype? Oh, yes. Thank you very much. I should do all of my work while I'm streaming because people catch my typos for me. This is wonderful. Thank you, Li Wen. Mm-hmm. Thank you, Olivier. You caught another typo. Should I be crediting you guys for this commit as well, or? So while we wait, I think this is pretty much going to be about it for tonight, because talking to yourself in front of your computer is really weird. I hope people have learned something. I hope if people have questions, they will ask them, because I'm going to close out just as soon as I can do this commit here, which hopefully isn't too much longer as this kernel builds. And when this kernel is built, we can just write this, and then this commit will be done. Oh, the name of the beer. That is an excellent question. I'm having a Cuvée Clarisse, which is described as a ruby red Belgian beer. Honestly, looks a lot more like a dark brown beer than a ruby red beer to me, but it is pretty tasty. So I would recommend. Compiling. I didn't strictly need to do this. I'm 99% certain that this will build just fine, because this is, it's been reviewed. Nobody's stupid or brave, if there is a difference between the two, enough to actually touch the bridge. So I'm pretty sure that this is going to build, but in the interest of avoiding pointy hats, I will wait for this compile to finish. And then I can go and have some dinner. Dinner is good. And we've done pretty well, considering that we've been going for an hour and 15 minutes. We've written a test, we've fixed 2 different panics in carp, and we have discovered what is wrong with the bridge that caused the existing test script to fail. So I think that's pretty good for an hour's work. Maybe next week, if people are interested in another stream, I will try to debug that bridge problem. And then we should decide, then we should try to figure out how we can test that. We could conceivably, actually, while we're waiting, so if we bridge 0, well, bridge create, let's say we create 3 bridges. Okay, so they do get different MAC addresses. Can we jail-c? That's not the jail we wanted, -c. Okay. VNet iron. Does it keep the same? It keeps the same MAC address. Okay, so jail-r. Let's destroy our bridges again. Let's create our jail again. Create a bridge. See what the MAC address is. Bridge 0 VNet iron, and now we create a new bridge in our host machine. And we still get a different MAC address, so I'm not entirely sure why. What happens if we create one in there? So I'm trying to figure out why we had a MAC address overlap. And we don't appear to have reproduced this, so this is interesting. I don't know why these bugs, why that test script triggered that bug, so that's going to be something to investigate tomorrow. Not tomorrow, next week. Next week, if and when we try to stream again. So no immediately obvious reason why this would happen, but let's just keep that the way it is. We've built our kernel and that's good, so we can just commit this. Oh, right, and I need to touch my UB key for it to commit. There we go. Congratulations, stream, you have contributed to commit R359641. You should all feel very proud. I feel we've accomplished something today. You know, we've fixed a bug, we've written a test, we've not committed them, but we'll give it a couple of days before to give people the opportunity to respond to the review. Not all reviews actually attract people who are interested in them and want to look at them, but nevertheless, we should give them a couple of days to give people the opportunity to look at them. I don't think this is a particularly urgent fix because nobody's come across the fact that carp is just broken in current. Nobody's come across it just yet, so we can give it a couple of days before we fix it. And I think with that, I will try to, I should finish my beer. Thank you all very much for joining me. This is a lot more fun when people listen in. We finished our commit, we finished our beer. With that, I bid you all a good weekend. See you next time if I decide to do this again. And hopefully the audio is gone now. But I'm going to quit the Jitsi thing. And this. And... Okay, you can still hear me. Good thing that you told me before I decided to start saying rude things about my audience. Should stop the stream anyway. Enjoy your weekend. Have fun. Write some tests. Write tests. Tests are good.